All right, I'm back, and I definitely know why this isn't working. It's because the stroke is still on, and it's so big and so tightly packed that it just looks blue. Yep, that was it. Okay, so turn that up to something. It can just be cool to then you can see the coordinate frame inside of the object. And I'm gonna actually move the camera in. So I'm gonna do what I talked about in the last video, which is let camera distance be 300, and then we'll change this to the variable that we just created, camera distance. Oops. Cool. And now we maybe do like cam dist divided by 2. That's kind of a nice perspective. And now we can change this. You could make it a variable if you wanted. Yeah, so I like that. I like being able to see like the coordinate system. So this is like the coordinate frame of the cylinder, in a way. Right, it's actually, yeah. I mean, it's one way of thinking about it, because the cylinder itself has a slightly different frame because, like I said, we have, oh no, that is it, because the frame is after all this stuff, which that's good. All right, so now we want to move the cylinder, which is going to be like our player. I want them to move around. So to make this just a little bit, give them a little more substance. Just 20. And I'm going to get rid of this weird effect and just make the cam dist 250. Okay. All right. Player movement. We're going to use key pressed. Now this is a function that will fire once every time a key is pressed. And inside of it, you can do stuff like key code, which detects, basically asks the question, what button was just pressed. And there's you can get the key codes for anything in JavaScript from this website, keycode.info. You just hit the key you want. So W, A, S, D. So yeah, W is 87. So we'll do, if key code is 87, do stuff. If key code is, I think it was 83, and then 65, 68. Nice. Okay. I'm just going to go for my own reference here. W, A, S, D. And now we are going to do something with this. So a very basic thing we could do would just be creating some variables called like player X, player Y, player Z, and just incrementing those values. But I'm going to try to keep things a little bit neat. So I'll do let player equal an object, and we're going to have an object, and within that object, one of the properties is going to be player position. I'm just going to do pause for position. And then position is an object itself, which will have an X, a Y, and a Z value. And this object, the player object, I want it to have a position. I'll probably want a rotation, velocity, acceleration, potentially a bunch of things down the line, depending on how far this game gets. But for now, we'll just leave position, and we'll update the position directly. So Now I have something else that I want to do. Keys down. And this is going to be an object as well. And then in this object, we're going to have a left-right property. So left-right is actually going to be an array that's 0, 0 to start. And so the first value in this array is for left, and the second value in the array is for right. And when there's 0, it means it's not being held down. When they're 1, it means it is being held down. And then I'm going to have a v, which is the resultant vector for this, which will basically be a sum of the components. So what that'll mean is if I'm holding down left and not holding down right, then this value will be 1. Right, theoretically, but actually I'm going to do -1 and +1 for left and right, because I want it such that if you're holding down both left and right, it cancels and this value becomes 0. But then if you're holding down just left, this would be -1. And then same thing with this. So now if you're holding down left and down, then this would be -1. I hope that makes sense. I'm thinking just right now, I was pausing there because I'm thinking maybe to keep it consistent, this should be negative and the other one should be 1, but as long as I keep it consistent, it's okay. Because it makes sense that down should be negative, you would think. Anyway, so this resultant vector, we're going to use this vector here to control the direction of the player movement. All right, so let's do this. So we'll have keys down, needs to be updated down here. So we'll do keys down dot up. The up down needs to become up down. So up down is an array. So I can do up down of 0, which is what I want for the up position, and assign it 1. So if someone hit the up key, the W key, key code 87, we want this value to become 1. And then similarly, if they hit the down, then we want the next value in this array, we want this value for down to become -1. Okay, and if they hit, I didn't do this right at all. This is S, this is A, this is D, I'm pretty sure. A is 65, D is 68, yes. Okay, cool. And then now we're going to update the left-right array. If they're hitting A, that's left, so -1. And if they're hitting right, D, I want it to be 1. 0, the 0 index, and the 1 index of the left-right array. Okay, this will all make sense in a second, I promise. So after all this gets done, I just want to console log the array keys down. We'll start with just left, right for the moment. Okay, so I'm going to hit A. Perfect. I'm going to now hit D. Nice. All right, so now I actually don't have those held down anymore, and it doesn't know that. And so to keep track of that, we're going to use the key released function. Now, yeah, it's important to note these functions, key pressed and key released, these are p5 functions that automatically are detecting input. So in this case, if the key is pressed, any key is pressed, all this code runs. Anytime any key is pressed. Any key is released, all this code runs. So if the key is released, we're setting it back to 0. And now we can show, so I press A, release A, left, release, right, release. Both at the same time, we get that. Perfect. Okay, next thing we need to do is we need to fill out our sum array, the resultant vector, this here. So this is going to be telling us basically, it's going to act like this. It's going to be the vector that we use that'll tell us where we're going, essentially. So this is now going to be v, and if it's, this would be like 1, 1, right? This would be 0, 1. You know what I'm saying? So like this would be up, this would be down, this would be if you're holding up left, if you're holding up right, if you're holding down right, down, down left. So this vector can only be, it's not, we're not having like an analog input with like a joystick. So this vector can only be something with ones, you know. Hopefully that makes sense. So to do that, we're going to do every time a key is pressed or released, we want to update the array. So we'll say keys down dot v equals, it's going to be keys down dot left right of 0 plus keys down dot left right of 1. So we're just summing that array essentially. The sum of the left right array, and then we want the sum of the up down array. So I can just copy this and replace LR with UD. Okay, and now we want to do that. I was going to console log this after this, but now we're going to do that here too. So anytime a key is pressed or released, we're updating that value. And after we update it, let's console log it so we can see what we're getting. And in JavaScript, as long as you're on the line, you can just hit Control-C and it copies that line. You don't have to select it, which is nice. Okay, so here we go. I'm gonna hold left. Gotta click the canvas first. Left, nice. So now that left-right value, that first element of our keys down.v array is -1. Now I'm going to hold D, it's +1. Now I'm going to hold both, it's 0. I let one go, let the other go. So that's nice, because that's the exact behavior that we want. So this is nice. This would be like up to the left, up to the right, down to the right, down to the left. Perfect. All right. So now we want to apply this to the player's movement. Okay. So we have a player object with the position property, and we're going to use that to draw our cylinder. So here's what we're going to do. We're going to translate player dot pause dot x, player dot pause dot y, player dot pause position dot z. And z we're not going to really need until we're jumping or moving up and down planes and slides or whatever. Nice. All right, now for example, call this player movement. For example, if we wanted to just see that this is working, we could say every frame, because we're in the draw cycle here, player dot position dot y plus equals 0.5. Now he's moving. Perfect. So next, we want the camera to follow the player. So we're going to assign the camera's origin to be the player's position. And nice. Sort of works. So it's at least looking at the player. The player's moving, the camera's looking at the player. Ah, right. So it's looking at the player, but it's not moving with the player. As you can see, it's still staying over here, and that's because we need to add this value. We need to add the player's position to the camera's position. And this will force the camera to move with the player. Now we actually might not want the Z. We'll see in a second why we may not want it once we get like the character jumping. But like now this works. So now we're following the player and the camera's moving with the player. Sweet. All right, so now we want to implement our movement. So we're going to use that keysDown.v vector to move the player. And notice the player is only going to be moving on 2 axes, right? That's why we only have like 2 values for the controls for that vector for now. Okay, so we need to do something here. Let me think. Got this vector. I will actually give this. No, I don't need to. Let's see here. keysDown.v. So I'm just going to update the player's position up top here because I don't want to be late in the update, which would cause like 1 frame of lag between the camera and the player if I update it down here. So I'm just going to make sure I just update it right at the top. Player.position.x equals keysDown.v of 0. Right, the first component is the left right. So we're really going to do plus equals. Nice. So if I hold down left, if I hold down right, if I hold down both, nothing happens. Oh, I'm not console logging that anymore. Should be. Why not? All right, let's see it. I'm sure you already believe me, but here we go. Left, right, both. Cool. Okay, next. We're going to do the other direction. Player.position.y plus equals keys down dot v of 1. Oh, so yeah, that's one thing when you have the auto refresh on and everything. You got to click the canvas before you start giving inputs, otherwise it's just going to write stuff over here. So yeah. All right, so now we can go left, we can go right, we can go up, we can go down. We can move on an angle even. Okay, great. Now the next thing is, one thing a lot of people do with this is they don't, or I don't know if they don't realize it, they just don't care, but it always annoys me if, like, you shouldn't be able to run faster just because you're running on an angle, but you can in a lot of situations where people don't take into account the fact that on the angle you're getting more speed because your x component is 1 and your y component is 1, and the resultant vector of that is more than 1. It's like 1.4, right? Because it's like square root of 2. So you want to account for that because you want the speed to be constant no matter what their direction is. So to do that, one easy way to do that is just a min function. Actually, what you'll want to do is like calculate the speed. So you'd be like, or we could just say let vmag vector magnitude equal keys down dot v, and we can use the built-in distance function in p5. So from 0, 0 to keys down dot v of 0 to keys down dot v of 1. And that'll be the magnitude. This is the same thing as like the square root of x squared plus y squared for this distance, or like the vector magnitude. But since we're not using p5 vectors, we're sort of just gonna do our own thing here. So this will give us the magnitude of the vector, and then this is perfect because this is what we're gonna have to do anyway to get it so that we're going to want to not move, you know, I'm holding left right now, but as you can see, like when I move the camera, he's not moving left relative to the camera, which is what we want. We want the player to always move in the direction that we're pressing, otherwise it'll be super frustrating for whoever's trying to play this game when they move the camera and have to like reorient their brain so that they're going the right way. So we're going to use the magnitude of the thing, vector, from the input, and here is where we can force it to be something we want. So we could say like, we don't have to get too fancy, we could just say vmag. I mean, you could do if statements, so this, I guess this is going to be a little bit fancy, but it's a cool thing to know. So this is called a ternary. So you say vmag equals, you give it a condition, vmag greater than 1, question mark. If so, 1. So we're saying vmag equals, if vmag is greater than 1, make it 1. Otherwise, it can be vmag. Because, right, if it's less than 1, it could be like 0, in which case there's no input, so we would just let it be 0. All right. So that takes care of that. So we call this normalizing. Normalize vmag to 1. Next, we want to going to do something with sine and cosine again. So we have the magnitude of v, and now we just want to get the sine and the cosine of v. And v is, so how do we do that? We need the angle. So we need this angle here, this theta. And the best thing, your best friend, is a tan 2, because this will just give you, you don't have to, like, if you were to do this yourself, you'd have to really think about which quadrant it's in and maybe do some conditionals for, like, you know, if x and y are both positive, then we want the angle to be such and such. But a tan 2 is just like, just handles it for you. So we're going to do v theta equals a tan 2, and then for a tan 2, you feed it a y and an x separated by a comma. So it calculates the angle from a specified point to the coordinate origin as measured from the positive x-axis, which is perfect. This is exactly what we want. So we're going to give it the y value, which is keys down dot v of 1, and the quote-unquote x value of 0. I'm only saying quote-unquote because, like, the x value, right, is really, this is the left right, this is the up down. Let's just write that here. This is the sum of left right. And sum of up down. Yes. Perfect. All right, I was just double checking that for myself. So now we have v theta, and hopefully I'm not losing people here, but so v theta is going to be like the angle. So this is v theta. Let's say we have a 1-1 situation like this, where I'm going, this is nice, okay. So you see the x and y axis here? In a 1-1 situation, I'm going up and to the right. And I think I just typed something here. Did I? I gotta remember always click the canvas first. Okay, 1-1 up and to the right. Now the magnitude is 1, because we forced it to be 1. And now the angle really should be a 45-degree angle to the x-axis. So let's see if it is. So right now it's 0 with no input. So that's 90. I should probably just convert this to degrees. You do that. Times 180 over pi. So do we get a 45-degree angle? Yeah. Now we get a 90-degree angle. Moving straight up. Let's move it straight back. All right, so things are sort of working how we think they would. At least we're getting nice we're getting angle values that make sense in some way. So, and I say in some way because, like, if they don't make perfect sense, sometimes, like, you'll just be like, okay, well, this makes sense if we add 90 to it, or if we add pi over 2 it. And so, like, in the end, you can just sort of, you're close and you can just add something to it because it's maybe out of phase for some reason. But it's okay as long as you just have to rotate a little bit more and then you're there. So we're probably going to see that in a second here. So we're close. So now we need the camera's angle. We need the angle of the camera relative to the origin. And to get that, we're going to need a sine and cosine again. So let me try to explain what I mean. So we want to figure out, we've got a camera somewhere, and we want to know the angle relative to the player. And so to do that, we're going to use a tan 2 again. So we're going to say, do I already have cam theta? Why do I feel like I already wrote that somewhere? I did. Okay, but I used it in this context of rotation, like the camera's rotation. Okay, so we're just gonna have to be careful here. Is a tan 2 of, now we need the camera's position values, it's x and y, which are this, right? This is the position. The camera's position is here. So this value and I'm only having a brain fart here because like this needs to be below because these things aren't properly defined yet. So is there any reason we can't do that? I think it'd be okay, right? Yeah, we'll move it. Okay, we're gonna move this to the top. Oh, orbit control still is on. It's weird. Okay. All right, camera stuff is up here now. Cam dist, all this stuff. We're going to take this position. This is the x position of the camera. We need that. That's going to go in our second value. Our first value is going to be the y position of the camera. Just going to go here. Okay, so nice. Now we have a cam theta. And we're going to use these both and say v theta needs cam theta. So we got to define cam theta first. Now v theta is going to be close. Let's see. Oh no, we're okay. We're okay. Okay. Here's where it comes into play. Keys down dot v. We're not doing this anymore. We're going to use vmag times the cosine of, and we're just going to hope for a second here because like even I'm a bit like, whoa, what's happening? But we're close. Times, this is what I mean when I said like earlier, like it's probably gonna be a bit off. We'll be able to fix it. Nice. Okay, so it's a bit off. So this is, I'm holding down right and it's coming right towards the camera. And I hold down left and it goes away. Hold down up, it goes left and right. So like we're there, we've done it, but now we just got to do a small adjustment, which I think we're going to do minus pi over 2. Because I did this yesterday, so I kind of remember. Yeah. All right, so there you have it. Now you have a camera follower with camera movement. in p5js. And I think I'll leave jumping for the next video.